Hi there, today I'm going to be solving question number 11 from section 3.3, and we are given a cylinder of volume 1000 centimeters cubed, and we are asked to determine the dimensions of the said cylinder in order to use the least amount of materials when building it. So let r equal radius and h equal height, and we get that the formula for volume is pi r squared h, and that the surface area is 2 pi r squared plus 2 pi r times h. And now we know that since we have two variables, we have to isolate one of them in order to be able to substitute it into the main function. So we get that 1000 is equal to pi r squared times h, which means that h is going to equal to 1000 over pi r squared. And if we substitute this into our function, we get that a of r is going to equal to 2 pi r squared plus 2 pi r times 1000 over pi r squared. And now if we simplify it, we get that a of r is going to equal to 2 pi r squared plus 2000 over r. Okay, so we've got this far, and now we have to find our derivative. Sorry, but before we find our derivative, let's go over the domain. So r has to be greater or equal than 0, has to be greater than 0 or equal to 0, and less or equal to infinity. And these values come from the fact that a radius cannot be negative, and it can be increased as much as we want as long as it's a positive number. Okay, so now we have to find the derivative of a of r, and a prime of r is 4 pi r minus 2000 over r squared. We have to let a of r equal 0 in order to find a minimum or a maximum value of r. Therefore, 4 pi r minus 2000 over r squared is 0. R cubed is 500 over pi, and finally r is the cubed root of 500 over pi. I know that this looks like an h, but it's a pi. Okay, pi. And this is approximately equal to 5.42. And now we construct a sign chart, and on our sign chart we are going to have a prime of r, 0 at this end, 5.42 in the middle, and then infinity. And now 5.42 is a 0. Here we have a negative sign, a positive sign, and if we analyze it, we know that these represents a minimum. And if we actually analyze those values, we get that a of 0, with a of 0, the area is approaching infinity. At a of 5.42, the area is approximately equal to 660.8, and that when a of r is approaching infinity, the area is approaching infinity as well. So now we know that a of 5.42 is our minimum. So the minimum of the surface area is approximately 661 centimeters cubed when r equals 5.42 centimeters, and that was part A. For part B, we are asked to find out if the dimensions that we got if the dimensions we got meet the requirements of the department. So we get that r is equal to 5.42, and h is 1000 over pi times 5.42 squared, and this is approximately equal to 10.84. So we have to do the ratio of height over diameter, and this is 10.84 over 2 times 5.42, which is 1 over 1. Therefore, it does meet the requirements of the department. Thank you for watching.